we're supposed to fully reduce the number of states and construct the reduced state table. So what we're going to do is we're going to partition our states. In other words, we're going to put them in different groups. And we're going to do this sequentially until we can say that we have gotten our table as partitioned as possible. So if that doesn't make much sense yet, it will after we go through it. So when we start, we're just going to say that our partition includes all of the states. So our partition 1 is going to be A, B, C, D, E, F, G, H, I, J, K, L, M, N, P. So that's partition 1. Now our next partition is going to divide them just in terms of their output. So let's look at their output, and we'll put in one partition everything that has a particular output, and then another partition everything that has a different output. And then if we have two different bits here that we could have, so there theoretically could be 4 different outputs, but here there are only 2. So you could have the output of 0, 0. If x is 0, then the output is 0. If x is 1, the output is 0. Or you could have the output 1 and 0. So those are our only 2 possibilities in terms of outputs. And if you look, you can see that states E and K are the ones that have the outputs 1, 0, and everybody else has the output 0, 0. So that will be our first, actually partition 2. So we're going to put E and K in one partition, and we'll put everybody else in another partition. A, B, C, D, E, F, G, well, not E, we just put that one elsewhere, H, I, J, and not K, L, M, N, P. Now we're going to look at the 0 and 1 successors. So what that means is you want to look at the successors. What is the next state if the input is 0, and what is the next state if the input is 1? And which partition is that next state in? So we have these 2 partitions. We have the partition that's EK, so that's one partition, and we have this other partition that has everybody else in it. And we want to look at what happens if x is 0. Then in what partition is the next state? So we'll start with E and K. So, and we'll start with 0. So for E, if x is 0, the next state is A. So I'll just put another little column up here. I'll just put x equals 0. What partition is the next state in? So I will label this partition alpha and this partition beta. So for E, when x is 0, the next state is A. A is in partition beta. So beta. Now let's look at K. When x is 0, what's the next state? It's A, and A is in partition beta. Okay, so there's no difference there. So that means that for our next partitioning, we're breaking this up, E and K will still be in the same partition because their next state, their 0 successor, are both in the beta partition. Now let's look at A. If x is 0, the next state is D. D is in the beta partition. For B, when x is 0, the next state is C. C is in the beta partition. When x is 0, and for D, the next state is B, which is also in the beta partition. I skipped C. So C, next state is A, which is in the beta partition. And I'll just go down for F, that's L, also beta partition, G, A, H, F. So each time as we're going through, it looks like if X is 0, the next state is always in that beta partition. So we didn't get anywhere with our 0 successors. We could not divide that any further based on our 0 successors. Well, let's look at our 1 successors. Okay, so now we're looking at what happens if X equals 1. What partition is the next state in when X equals 1? Well, for state A, when X is 1, the next state is H, which is still in that beta partition. For B, the next state is I, which is in the beta partition. For C, the next state is A, which is in the beta partition. For D, the next state is M, which is in the beta partition. I'm going to skip E for now because it's in a different partition. We'll come back to it. For F, next state is E in the beta partition. No, E is not in the beta partition. Oh, okay, we finally found one. Okay, so E is in the alpha partition. So alpha partition is the partition containing E and K. For G, when X is 1, the next state is A, that's beta. HJ, that's beta. IA, that's beta. By the way, this alpha beta, this is just me. This is not standard. I don't know of anybody else who does this. It just came to me, actually, so I'm just using it as an example. So this is not, this is just my method. Okay, and then J, the next state is P, that's the beta partition. We're not going to do K. L is, next state is A, that's the beta partition. And M is K. K is the alpha partition. You see right here, the alpha partition contains E and K. And then N is A, that's beta, and P is A, that's also beta. Okay, so what we found now is that we can partition our second partition here. We can separate out F and M, because they have different 1 successors. So we have F and M, and then we have everything else, A, B, C, D, G, H, I, J, L, N, P. Okay, now let's go back and look at our E and K and their 1 successors. So E, the 1 successor is A, which is beta, and K, the 1 successor is A, which is also beta. So they have the same 1 successors, so they will stay in their own partition. Okay, well now here with step 4, we now have 3 partitions. So I am going to call these partitions, I will call them, I don't know what made that happen. I will call them gamma and delta and epsilon. So I'm just, I guess I like Greek letters. Okay, so now let's look at the 0 successors. So we'll start over now with our new partitions, and we'll look at our 0 and 1 successors for them. So X equals 0 and X equals 1. Okay, so I'll start with E and K and X equals 0. So E, when X equals 0, I have A, and for K, when X equals 0, I have A. Both of those are in this epsilon partition, so that's not going to change. So for P5, we'll still have EK. Now let's look at FM. So F, the 0 successor is L, which is in the epsilon, and for M, the 0 successor, is G, which is also in the epsilon. So these are going to be the same. Okay, so now let's look at all of the rest of our states and what their 0 successors are. So for A, we have D, which is an epsilon. For B, we have C, which is an epsilon. For C, we have A, which is an epsilon. For D, we have B, which is an epsilon. G is A. Now look at H. H has a 0 successor, F. Now F is in a different, all the rest of these so far were all in epsilon. All of these had their 0 successors were all in this same group. But H, no, its 0 successor is F, which is partition D. So we know it's going to be different. I'll just start it off over here, and we'll see if we get anybody else in that partition. Okay, then I is A, that's still epsilon. J is N, that's epsilon. L is A, N is A, P is A, so there's nobody else. So it's just H. And then we're left with A, B, C, D, G, I, J, L, N, P. Now we're going to look at the 1 successors. So we're going to start partition 6 here. And I want to keep this all on the same screen. So I'll come up here for partition 6. And we're going to look at our 1 successors now. So now we'll look at our 1 successors. And let's start with E and K. So E and K, their 1 successors are both A. So those are in the same partition. So they'll be together, E and K. H is going to have to be together. It's by itself. F and M. So F has as its 1 successor E, and M has as its 1 successor K. Those are both in the same partition. So F and M both have their 1 successor in the same partition, so they'll stay together. Okay, so now let's look at everybody else, just to make things a little easier here. I'm just going to cross through these so I don't look at them. So these are the ones we've already done. And now we want to look at the 0 successors of everybody else. Now notice that we have this big group here, A, B, C, D, G, I, J, L, N, P. If the 1 successor is one of those, it's going to stay in that group. But if it's one of these other ones, E, K, F, M, or H, it's not going to be in that group. So that's really what we want to be looking for. So I'm going to be looking to see if anybody has a 1 successor that's E, K, F, M, or H. So let's look at that. So first A has as a 1 successor A has as its 1 successor H. That's not in this group. All right. And D has as its 1 successor M. All right. That's not in that group. Let's go back and look at everybody else. So everybody else is staying with its 1 successor in this group, A, B, C, D, G, and so forth. So everybody except for A and D will stay together. So let's go ahead and put them. So that would be B, C, G, I, J, L, N, P. Okay, now A has as its 1 successor H. That's this partition right here. And D has as its 1 successor M. That's a different partition. So A and D don't go together. They go in their own partitions. All right, so now we have that. Alright, so time to start over again. I'll erase all of this. Alright, so now we're going to have P7, and we know that H, A, and D are going to be in their own partitions because there's nothing else to do. Let's look at zero successors. Let's start with E and K. So E, zero successor is A, K, zero successor is A. Those are in the same partition, so E and K will stay together. Now let's look at F and M. F, its zero successor is L. M, its zero successor is G. Let's see if those are in the same partition. So here's, what did I say that was? L and G. So here's L, here's G. They are in the same partition. So F and M stay together. Okay, now we need to look at everybody else. Like before, I'm just going to cross through the ones that we've done so I can more quickly scan through. H, A, D, E, K, F, and M. Okay, so we're looking at the zero successors. And we want to separate out those that have zero successors that are in different partitions. Well, remember, A is in its own partition. So anybody who has a zero successor that's A, that's going to be in one partition. So let's find those. So here we have an A, an A, an A, an A, and an A. So all of those will be, oh, that's interesting, it changed colors. All of those will be in the same partition. So that would be C, I, L, and P. Okay, now let's look at the others. So we are left now with B. Oh, did I miss G? Let's see. Yeah, it looks like I missed G, so this needs to have a G in it. So, C, G. Okay, so who was I left with? Just B and J? B and J. Yeah, so BJ. Okay, now we'll look at the one successors. So let's take a look at the one successors. So H, A, and D, they're going to stay. E and K both have A as their one successor, so they'll stay. F and M have E and K as their one successors. Well, E and K are in the same partition, so F and M will stay as they are. And C is A, G is A, I is A, L is A, N is A, and P is A, so they'll stay. Now B has I as its one successor, and J has P as its one successor, and I and P are in the same partition, so that's not going to change. Alright, so we are now done because the partition we have here was the partition for the zero successors, and then the one successors didn't change anything, and so going back to the zero successors won't do anything because we've already done that partition, so we are now done. So we have 1, 2, 3, 4, 5, 6, 7 partitions. So we can do our reduced state table, and we can pick a state from each group. It doesn't really matter which one, to kind of be our representative state. So let's pick A and B and C and D and E and F and H. So I just picked those. It doesn't have to be those. And then we'll make our reduced state table. So what we will need, so I will have to go to another screen, so hold on. Sorry. Oh, I'm just pasting it all over the place, just in the wrong place. Alright. Technical difficulties. Alright, let me just write down what the partition is. We have A was in its own group, and then BJ, and then C, G, I, L, N, P, and then D, and then E, K, and then F, M. And we need to have our present state, our next state, and we have a next state for x equals 0 and x equals 1, and we have our output z for x equals 0 and x equals 1, and we chose A, B, C, D, E, F, and H. And then we can look at our original state table and see for an element in that partition what is the next state. Well, for A, it's D and H, and so we can use those because those are names that we have right here. So we can say D and H. And then for B, we have C and I. Now let's remember C was in this partition and I was in this partition. So C and I. So C and I are both in this partition, which we labeled C. We labeled this one B, A, D, E, F, and looks like I left out H here as a partition, but that was one as well. So it was C and I, and so those are both C. Those are both partition C. And then for C, our state table had AA, but we can just use that. And then for D, we had BM. Okay, well B, that's our label up here, so that's B. And then M is in our partition that we called F. E, A, F is LE, so let's see what those are. L is here in partition C, and E is E. And then H was FJ. And let's see, F, we called that one F. And where's J? Here's J. J's in B. Alright, now we need our output, so we can just find the output for A, B, C, D, E, F, and H. And those will be our outputs over here. So, A, B, C, D, E, F, and H. Notice those are all 0, 0, except for E, which is 1, 0. Alrighty then, let's see. Let me check this. ADH00, BCC00, CAA00, DBF00, EAA10, FCE00, HFB00. Amazing, I have the same answer. Okay, so that is your reduced state table.